Hey guys, it's Miss Fearing here. Welcome to Unit 7, Notes 3. Today we're going to go ahead and look at some combinations. So the learning target is I can use combinations to determine the number of outcomes for a given situation. So first example here, a basketball league has 5 teams. 2 of the teams are choosing to play one another. How many different possible matchups are there? Make a list. So the first thing I'm going to do here is I'm going to give my teams names, I guess you would call them. I'm going to call them A, B, C, D, and E. Those are my 5 different teams. So now that they all have a name, I can go and I can make a list of matchups. So A can play B, A can play C, A can play D, or A can play E. I'm going to go ahead and I'm going to look then. I know that B can play A, B can play C, B can play D, or B can play E. Moving on to C being the matchups. Matchups with C are C and A, C and B, C and D, C and E. And then you're going to see the same thing for D, D and A, D and B, D and C. D can't play D, so I have D and E. And then for E, we have E and A, E and B, E and C, and E and D. So when we're looking at matchups here, what we really have to think about is, does it really change it up if A plays B or B plays A? That's really the same kind of deal going on here. So this really is a repeat of a game that or a matchup we already made. So we're going to go through and we can look and see what other ones we can get rid of. Well, C playing A is the same thing as A playing C, so we can really get rid of this one. Same with DA and EA. Now I can go ahead and I can look, B playing C is the same thing as C playing B, so I can really get rid of this one. And then D and B and E and B, those are all repeats. Keep looking through my list here. C playing D, D and C, same thing. E and C, same matchup there. And then lastly, I have D and E and D. Again, that's the same matchup. So those ones really don't matter. So when I'm looking at how many matchups I have here, I'm really looking at these ones here. And if I count them up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 different matchups that I can make. So when we're looking at the difference between yesterday's notes and today's notes, yesterday we didn't get rid of these similarities because A and B and A were different things. Order mattered. That's what changes up for combinations today. So a combination is a group or listing of objects in which order is not important. Okay, and we're going to look for words that things that say groups, or pairings, just like we were kind of doing with our teams, pairings. Those words tell me order is not important. It doesn't really matter how you're put into a group. You're in a group. Or it doesn't matter if I pick you or your partner first to pair you up. You guys are already a pair. It doesn't really matter how you got there. So a combination is when order is not important. Our formula is going to be pretty similar, except we're going to look at NCR now. So C tells me it's a combination, and that means I have a different formula. I have n factorial divided by n minus r factorial times another r factorial. So basically what that's doing is that's getting rid of all those repeats for us. We're counting how many are repeated and we're dividing by them, which is going to make our number a smaller number. So let's go ahead and just look at evaluating these combinations right now. I have 6C2. So if I have 6C2, I'm just going to plug that into my combinations because it's a combination. I have 6 factorial because my n and my r still stay the same as they were yesterday. My n is my total. My r is going to be my number I'm picking or choosing from. So then I have 6 minus 2 factorial times another 2 factorial. We have that extra r now today. So when I do this, I get 6 factorial divided by 4 factorial times 2 factorial. So if I write this out, I get 6 times 5 times 4 times 3 times 2 times 1, 4 times 3 times 2 times 1 times another 2 times 1. So we can cross things off, 4, 3, 2, 1, 4, 3, 2, 1. So I end up getting 6 times 5 divided by 2 times 1. 6 times 5 gives me 30 divided by 2, which is going to give me 15. So now I have 8 choose 3. So again, 8 is my total. That's my n. Divided by 8 minus 3 factorial times my another r factorial. So if I simplify that, I get 8 factorial divided by 5 factorial, 3 factorial. So think back to our notes yesterday. We said that we can kind of cancel out the largest number there with the rest of the large numbers on top. So basically the 5 factorial on the bottom can disappear with all of the 5, 4, 3, 2, 1 on top. So I am only going to have 8 times 7 times 6, because the 5, 4, 3 is going to cancel out. And on the bottom, I'm going to have 3 times 2 times 1. So if I go ahead and I put this into my calculator, I'm going to end up getting 56 as my answer. So here's our first word problem. We have a group of 7 seniors, 5 juniors, and 4 sophomores who have volunteered to be peer tutors. Mr. Picard needs to choose 12 students out of the group. How many ways can the 12 students be chosen? Well, this is a combination because order doesn't really matter how I pick these 12 students. It's not like the first person chosen is the best tutor. I'm not saying that. I'm just saying they're going to be a tutor. So order doesn't matter, so I know that I'm going to have a combination here. So we have to figure total and then how many we're picking. So total of students I have here, I have 7, 5, 4, so I have 16, and I'm going to choose 12 of them. So if I write that out, I'm going to get 16 factorial divided by 16 minus 12 factorial times my 12 factorial again. Simplify, I get 16 factorial divided by 4 factorial, 12 factorial. Now I'm going to cancel out the largest factorial on the bottom with the rest of the numbers up on the top. So I'm going to cancel off the 12. So once I get to 12 on the top, I'm going to stop writing. So I'm going to have 16, 15, 14, 13. So 13 would cancel. Next would be 12. I'd cancel them off. So on the bottom, I only have 4 times 3 times 2 times 1. Multiply those across and get your number on the top. So 4, 3, 6, 8, is what I got. 24 on the bottom. Now you can divide last. So when I do that division, I get 20 groups. So 1,820 different groups can be made. So this example here, you and 6 friends are going to eat lunch. You can only take 2 people in your car. How many different combination of friends can ride with you? Well, I see I'm looking for combinations right now. Order doesn't really matter in this situation. I'm still going to put 2 friends in the car. Yes, it's kind of nice that they get to ride in the car with you, but it really isn't important how you pick those 2. They're just being picked. So order is not important, so I'm going to have 6 total, and I'm going to choose 2 of them. So when I do that, I'm going to get 6 factorial on the top, divided by 6 minus 2 factorial times my r again, so times my r factorial again. If I simplify, I get 6 factorial divided by 4 factorial, 2 factorial. So I'm going to start writing on top, and I'm going to stop when I get to the largest factorial number on the bottom. So I'm going to stop when I get to 4. So I'm going to get 6 times 5. The rest would be the 4, 3, 2, 1. And then I still have 2 times 1 on the bottom. So 6 times 5 gives me 30. 2 times 1 gives me 2. This answer would give me 15 combinations, or 15 different ways that I could pick those 2 friends from the 6 I had total. So here's our last example where I'm going to throw something new at you. So I want you to go ahead and pause the video, try this one on your own. Remember, we're talking about a combination here. And then come back, unpause the video, and check your answer. So when I had a gym coach, I was selecting a team of 4 athletes from 14. I went and I did a 14C4. So when I wrote this all out, I ended up canceling the 10 factorial on the bottom with the 10, basically the 10 factorial up on the top that happens there. So I was only left with 14 times 13 times 12 times 11 on top. And then I still had the 4 times 3 times 2 times 1 on the bottom. So when I multiply those out and divided, I ended up getting 1,001 teams. If you got anything different, please come chat with me before moving on in the video.